Now that we have the problem statement clearly defined, let's have a look at the business solution blueprint. So developing the blueprint for the business solution is actually a structured process. Now we have a high level process structured and formulated into the simple flowchart. Now this might be fairly different in different organizations. Most organizations kind of tailor the process with respect to their requirement. But this is a high level generalized approach, which can be fairly adjusted in any environment. Let's understand the flow. The process begins by defining the problem statement. Now, this is a step which we have done in the previous slide with the help of SEQ. So we've understood the situation, complication, and the key question that needs to be answered, and then we have clearly defined what is the problem statement. Now, once you have the problem statement defined, the next step is to delineate the problem statement. Now, this is a process which involves team brainstorming. So a bunch of guys to sit together with a common shared goal of solving the problem. Now, a team is actually important over here because you need diversified inputs rather than a biased input. The moment you have a team together, the brainstorming process becomes more healthy. Now, this is done using a simple factor map. We'll get into the details and I'll show you a basic factor map in the next slide. But for now, just assume that factor map is a way to organize your random thoughts into a structure. So let's say you have the problem statement defined and you're trying to understand what are the different factors that will help you to that kind of affect the problem. And you're trying to understand what are the different factors. So you randomly sit and you start discussing different topics. Now till this point of time, you don't really have data with you. So this is a data agnostic approach at this point of time. You sit in a room as a team, you try to understand what could be different factors that are associated with this problem and that definitely have an impact with this problem. So that's when we create the factor map. Now, once you create the factor map, the next step would be to design the hypothesis-driven matrix. So each factor that you identify in the previous step will have an associated hypothesis. Hypothesis could be in a negative way or a positive way. So for example, let's say one of the factors that you believe that has been a problem is, let's say, customer churn. So your hypothesis associated with this factor would be an increasing customer attrition has resulted in declining profits. That hypothesis. That is the hypothesis. So this hypothesis could be a true one, could be a negative one. Irrespective of that, that's an insight. So you could use data to understand whether your hypothesis is true. If it's true, great. If it's false, that's a counterintuitive insight. Now, once you have the hypothesis-driven matrix, which is a collection of all the factors and their associated hypotheses in a structured way, you move on to actually solve the problem in a tangible fashion. So you know what exactly is your problem statement. You have fairly a high level understanding of the different factors that you have, that you believe are a part of the problem. You have an associated hypothesis with each one of them. And now you move on to understand how you can acquire data to solve the problem. So this is where the data-driven approach begins. Machine learning problems kind of originate just one step before this. Like you have a hypothesis that could be a specific problem, and one specific problem can actually lead to a machine learning solution. Or it can come later when you're talking about key action items. We'll talk about this in a while. The next step would be to solve the problem data acquisition. Once you have the data acquisition done, you'll go on to understand EDA. Like you'll understand the data better. So you'll do exploratory data analysis, you'll do hypothesis testing, and you'll have an answer for each of the hypotheses that you had defined in the previous step. Now, when you have all the answers for all the questions that you have asked, the next step would be assimilating all the insights and defining key action items. So once you have all the insights neatly aligned together, you would define, okay, fine, with this current scenario and these problems impacting the problem, these factors impacting the problem in such a way, we understand that the key action items would be first to increase something, which means which will eventually lead to like, okay, develop a machine learning product for that, or reduce a problem's impact. So that will be there'll be some strategic realignment, or improve CSAT, customer satisfaction. There'll be an associated outcome with that. So there'll be like an endless list of action items and different priorities that would come after you assimilate the insights. So let's take it more tangibly. You define the problem statement, you have the SEQ already done. You delineate the problem and you do team brainstorming activity to come up with a factor map. Let's look at what would you understand by a factor map. Factor map is, in a nutshell, a simple process to have a structured brainstorming exercise documented on paper. So how would this go ahead? This would be connected with the SEQ. So if you remember in the previous slide, we talked about SEQ, where we have asked, okay, fine, this is the complication, and what are the key questions that need answers to move ahead? So the key question over here is, what are the key factors that led to the financial crisis? Now, this is where the team starts and begins solving the problem. So in the factor map, we start identifying what are the key factors that led to the financial crisis. Now, there could be an endless list of factors that could possibly be associated or not associated. But then when you move ahead with this approach, you have to be first data agnostic. You don't really have to make any assumptions about the data. That even whether you will have the data, that's a different thing. So let's look at a basic factor map and a hypothesis matrix. So here, this is a sample factor map, and this is by no means an exhaustive factor map, but this is just representative of the one I would believe you should create for your problem statement. So the factor map starts with the key question. What are the key factors that led to the financial crisis? Now, there will be several factors that you could think about. When you sit together as a team and you try to build an exhaustive connected map, it could be a structured, layered approach. Let's say, so this is a very simple one. You believe that fraud transactions have increased, right? So the number of fraud transactions could actually be a problem. Customer churn could be a problem. Microeconomic factors, macroeconomic factors, customer service, which could be poor or good, marketing campaigns, which are not really effective right now, and the overall brand image. Is there a tarnished brand value? How do people perceive your brand? All of these factors could actually lead to your declining profits. Now, if you look at a more realistic version of a factor map, that would be an outcome from a brainstorming exercise within a team. It's going to be really complex and really exhaustive. This is just a miniature version of the factor map I wanted to showcase to you so that you could actually design one for your problem. Now, a real one would actually have several factors under each of these factors. So you have customer as a dimension, and within customer you'll have customer related attributes, and you would believe that all of these attributes in some way impact the kind of outcome we have over here. So on. So this is how you would actually whiteboard and document a brainstorming exercise, which you believe that would be one of the reasons for solving the problem. Now, once you have the entire factor map documented, each of these factors would have an associated hypothesis. So you create the hypothesis-driven matrix. This is a step which follows right after factor map. So if I go back to the business solution blueprint, we define the problem, we delineate the problem statement, that is, we use team brainstorming with the factor map. Once you have the factor map, we design the hypothesis-driven matrix. Now, in the hypothesis-driven matrix, we create an entry for each of the factors we believe are a part of the problem. So I've just showcased a few to enlist how it looks like. So let's say one of the factors were customer churn. So your associated hypothesis would be higher customer churn has resulted in declining profits. Now, what is your observation for that? Observation will come in once you have data and you look at the data and you do exploratory data analysis. So this column over here would be filled only after the next step when we do data analysis, after data acquisition, and then followed by EDA and hypothesis testing. A couple of other macroeconomic factors would be like, okay, Brexit and GST has resulted in declining profits. So you would like to see the kind of profit trends before GST, after GST, before Brexit, after Brexit, and so on. Customer service could also be another factor. So poor customer service has resulted in customer attrition and hence declining profits, and so on. So there'll be a long list of all factors over here and your associated hypotheses over here. Now, once you have all your thoughts documented neatly over here, the ideal next step would be to actually go ahead and test them. So that's when you go and acquire data, test your hypothesis, do some exploratory data analysis, and fill in the observations over here. Some of them might be true, some of them might be false. So for example, let's say You believe that high customer churn has resulted in declining profits, and you believe this is one of the most fundamental factors that has affected your problem, which is declining profits. But when you look into your data set and you try to do some analysis, you don't see a trend that kind of works in synchrony, in harmony with this hypothesis. So this observation might be false, that this is not the case. So when it's false, that's also a counterintuitive insight. The next one would be, let's say, this macroeconomic factors. And you believe that macroeconomic factors did have an impact on the end outcome, that is, declining profits. When you look at the data, you do some analysis, and you do see that. So that would be a yes. This would be a true hypothesis. So when you follow this fashion for several different hypotheses, you have a matrix where you have documented the validity of each hypothesis, and you have neatly organized the impact of each of these hypotheses. Now, in a nutshell, we would actually use this as a key answer sheet, assimilate your understandings and the insights combined together, and kind of find a solution to your problem. So this is where we go back to the same question exercise. You start with the question, what happened? You try to understand why did it happen, and then you understand when did it happen again, or now what, so what. So this part, the factor map and the hypothesis-driven matrix together combine and give you answers to why did it happen, right? We have still not reached now what, so what, or when will it happen. We're still in the inquisitive phase. So coming back over here, we move on from defining the problem to understanding the factor map, designing the hypothesis matrix, acquiring data, performing EDA and hypothesis testing. And once we have all answers neatly documented, we would assimilate the insights and define key action items. So once you have clear understanding, okay, fine, each of your hypotheses is either true or false. Whenever an hypothesis is true, that will have a certain associated action item. Whenever a hypothesis is false, that would also have certain action items. So let's say based on some understanding you saw in your hypothesis-driven matrix, you understand that customer satisfaction has been decreasing, and that is the reason for declining profits. So one of the key action items would be increase customer satisfaction. And how would you do that? It could be through developing a machine learning algorithm, which would result in a chatbot. I'm just giving a random example. So let's say the designed outcome would be, okay, fine, customer satisfaction is decreasing because of poor customer service. So one of your ideas would be, okay, fine, to serve the customers better, you would take everything digital and provide a chatbot through which the customer can interact and get instant answers. So that would be a tangible outcome. So this would become eventually one machine learning use case. Now, some action items will not necessarily require machine learning as an outcome. So let's say you're saying, okay, fine, reduce operational expenses. So that's like reduce XYZ probably. And that will become, okay, you need to have strategic realignment as a solution. Something like that. So in this fashion, your key action items will have a list of priorities, actions, and the outcomes expected from those actions as a solution path. So all of this together kind of summarizes the blueprint for your solution. So you define, delineate, design, then perform, assimilate, and finally define key action items. And once you solve all of this, you kind of believe that your problem is going to be solved. So till this point, what we have looked into is we have gently studied what happens necessarily before even a machine learning project is born. So tomorrow, let's say you're talking about a machine learning use case where you're trying to predict customer churn. So your end goal is to predict whether a customer is going to leave your bank and go to somebody else. That's the prediction you're doing. It's a classification algorithm. So that algorithm will have some history, that use case will have some history, that why are we even trying to solve this problem? So this blueprint is a means to understand the history of how did we arrive at the problem. The most use cases that I have seen available over the internet or taught in any courses kind of tend to avoid this business impact. And that's really a wrong approach. When you're talking about solving a machine learning problem, even though we have not delved deeper into each of these steps, it's kind of important to understand how does problem solving work in any industry, and specifically when you're solving a machine learning problem. So that's the basics of developing a business solutions blueprint. We have looked into the different processes. We have studied the factor map as well as the hypothesis matrix. And we have finally reached the point where a machine learning use case germinates. So in the next step, now that we have defined the problem and reached to a tangible outcome, let's look into a specific use case for a machine learning project.